Welcome to our 1.4 video on reasoning and algebra. Our essential question is, how is deductive reasoning used to prove statements true? First, we're going to add some properties to our notes. So I'm just going to talk through these, but I suggest you listen and then add them later. Our first property is the addition property, which says if A equals B and you add C to both sides, they will still be equal. The subtraction property says if A equals B, then A minus C equals B minus C, still equal if you subtract the same thing from both sides. Multiplication property says if A equals B, then A times C equals B times C. So multiplying by the same thing on both sides will leave the two sides equal. The division property says if A equals B and C does not equal 0, because we can't divide by 0, then A divided by C equals B divided by C. The reflexive property says A is always equal to itself. The symmetric property says if A equals B, then B equals A, basically that you can flip the two sides of the equal sign. The transitive property says if A equals B and B equals C, then because both A and C equal B, A must be equal to C. The substitution property says if A equals B, then B equals A, and this is that you can plug in for something else. We'll see this later. The distributive property says if A is multiplied by parentheses B plus C, then A plus B, then it really equals A plus B. If A times parentheses B plus C, then we have AB plus AC. Those two statements are equal. I suggest that you pause the video and finish getting any of that in. One thing to quick note, notice that my abbreviations for substitution and subtraction are really close. I have a T on my subtraction abbreviation and an S on the end of my substitution abbreviation. It's important to remember those so that you know whether you're subtracting or substituting. Okay. Now we'll look at example 1. Example 1 says, name the property that justifies each statement. So, first one, if x equals y and y equals 4 and y plus 4 equals 3x, then x plus 4 equals 3x. So we know that x equals y, and we're plugging in x instead of y. We are substituting. If we know x plus 4 equals 3x and then 4 equals 2x, what I've done here is I've really just subtracted x from both sides. I've simplified, but I've simplified by subtracting, so I'm using the subtracting property. Next, if angle P is equal to angle Q and angle Q is equal to angle R, then and angle R is equal to angle S, then we can conclude that angle P is congruent to angle S. Because there's a chain of all of those pieces being congruent, I misspoke. That should be congruent. If angle P is congruent to angle Q, and angle Q is congruent to angle R, and angle R is congruent to angle S, then angle P is congruent to angle S. Remember, the tilde on top is for congruent. This is the transitive property, right? There's that linking between Q and Q, R and R. So we've got the transitive property. Here we have segment XY is congruent to segment XY. That is the same, right? That's like A equals A. That's the reflexive property. Lastly, if the measure of angle A equals 45, and 45 equals the measure of angle B, then the measure of angle A equals the measure of angle B. We've got a couple options. This could either be the substitution property, right? I'm plugging in angle B for 45, or it could be the transitive property. I'm linking them together. Either would be correct. Next, I'm going to show you how to write an algebra proof. In general, we format our proofs in 2 columns. So your first column is your statements. Those are like the steps of your work. The second column is your reasons. That is why you can do that next step. Our first row in a proof should always be what you're starting with. So in this case, x minus 5x minus 12 equals 32 plus x, and we just say given, right? There's no reason for that. We were just given that. Next, we're going to simplify. Next, we get 5x equals 44 plus x. What we've done here is we've really added 12 to both sides, right? We don't write the added 12 in our proof, but that helps us figure out that we're using the addition property as our reason for that. That's how we get this next line of work. A proof is kind of like a problem without your middle steps, just the equations, and then your reasons next to it. Next, we can see that we have subtracted x from both sides to get 4x equals 44, so we say the subtraction property as our reason. And then finally, we divide by 4 on both sides, and so to get x equals 11, and we list the division property as our reason. Okay. On the next page, we'll do a couple more proofs. So for this proof, it says, suppose that A, B, and C are collinear, where B, with point B between A and C, solve for x. So we know that AB is 15 minus x, BC is 4 plus 2x, and we know the whole segment is 21. So first, we're just going to list our given information, right? Those were all the pieces we were told. That is given. Next, we know that AB plus BC, those two smaller segments, add up to the whole segment AC. And this is going back to chapter 0. This was the segment addition property that tells us that. Once I know that that statement is true, that the two pieces AB and BC make up the whole segment AC, I can substitute those values in. So I know that AB is really the same as 15 minus x. I know that BC is really 4 plus 2x, and I know that AC is really 21. And I'm using the substitution property to put those in to what I had in number 2. Then I can simplify. We also call this combining like terms, right? I'm just combining like terms. I'm combining my x's, I'm combining my 15 and my 4, and then I'm subtracting 19 from both sides. I am using the subtraction property to get my answer as x equals 2. Okay. Here is our try now. Try and write a 2-column proof for this. Pause the video and check in when you're ready. Okay. So, first, we're told that LM bisects KLN. That's given. Always our first row. Our second row is that the measure of angle MLN is equal to the measure of angle KLM. Notice I changed that N to an M. This is because of the definition of bisector. You can use definitions in your proofs as a reason. Bisectors cut things exactly in half, and we know that they have to be equal because of that. Based on that, we're able to substitute those values in. 4x equals 2x plus 40. That's in our picture. We probably should have listed that in our first row with the given information. We're using the substitution property to plug those numbers in. Then we're subtracting 2x from both sides. Notice how important it was that I did SUBS and then SUBT, so I know when I'm substituting and when I'm subtracting. And lastly, I'm going to divide to get x equals 20. Awesome. That is the conclusion of our 1.4 video on reasoning in algebra.